We're going to look at the second part of Appendix 4, which is looking at complex numbers. Yesterday we looked at how to add and subtract. Today we'll look at multiplying and dividing. Okay. One thing we touched on at the very end of the lesson yesterday was what I squared is equal to. Okay. Anytime we multiply or divide, I squared is going to come up a lot. Stephen, do you remember from yesterday what I said I squared equals? Not sure? Anybody help him out? Yeah, I squared was -1. Okay, we went through the proof of that yesterday, so I'm not going to go through it again. But that is something very important we need to know. Okay, I squared equals -1. Okay, so anytime you do any kind of arithmetic, if you end up with I squared in the final answer, you didn't do something. I squared should always be changed to -1. Do not ever leave I squared in the final answer. Okay. When you do problems on the test, if I give you some multiple choice questions, there will be some where I squared is in the final answer. That is automatically wrong. Okay. Do not leave I squared in the final answer. All right, so let's look at how we do a product of complex numbers. We've got A plus BI, C plus DI. Basically, the way we multiply complex numbers is to use this pattern. Kylie, have you seen that kind of pattern before? Do you remember there's sometimes a word we use to describe that? Yeah, it's like FOIL. Some people call it the distributive property twice. But the idea is when you multiply complex numbers, okay, you multiply the A and the C. Okay, those are the first terms. The outer terms are the A and the DI. The inner terms are the C and the BI. And then the last terms are BI times DI. And that's where you get an I squared, when you multiply BI times DI. Now, A, B, C, and D will all be numbers. Those are not going to be letters when we do an actual problem. Okay, it's going to be something like that. Okay, so it's using a technique that you've already used before. Okay, so let's try multiplying these two numbers together. Melissa, can you tell me the first two things I would multiply here? Yep, if you're following that FOIL pattern, you're going to do 2 times 1. Okay, Hunter, what would be the next thing that I would multiply?
-2i, or the 2 and the -i.
Yep, and he already said what it's going to simplify to, but the first time through I'll just write it out. Plus the 2 times the -i, which is going to be -2i. Yep. Okay, Ashley, can you tell me the next two things I multiply? So we did the first, we did the outer. What's the next letter in FOIL? How do you spell FOIL? Yep. So I stands for inner. Okay, what are my inner terms here? The 1, yeah, and nope, the 2 is on the outside. The I, yeah. So we're going to multiply the 1 and the I. And the last is L. And Stephen, what are my last terms here?
I and the other I.
Yep, I and -I. Hey, let's simplify that out. Kylie, 2 times 1? 2. Melissa, 2 times -I? -2i. Okay, Ashley, what's 1 times I? Yeah, just 1i, or we could just write I. And now the last part, Hunter, let's look at it in 2 steps. We have a positive I times a negative I. What's a positive times a negative?
Negative. Oh, yeah,
Negative. And what's I times I?
I squared.
I squared. That's where we get that I squared from. Okay? So now we can simplify a little bit. We've got 2. Stephen, what's negative 2I plus I?
3, negative 3i.
If you subtracted, it would be negative 2I. Negative 1I. Good. So negative 2I plus 1I is negative I. And Kylie, what did we say I squared was? I squared is negative 1. Now be careful. You still have that negative in front. That's the subtraction sign. And now we have another negative from the I squared. Okay? Next step. I have minus 1. Melissa, what's going to happen to that? Becomes a plus 1. And now my last step, combine my like terms. Hunter, what's 2 plus 1? 3 minus I. Okay, so anytime you multiply 2 numbers together, your final answer should always look like this. Real part, then imaginary part. Okay, any questions on that? Okay, so that's how you multiply 2 complex numbers. Now, what if you had something like this? What property would you have to use to do this one?
Distributive.
Yeah, this would just be distributive. It wouldn't be as complicated as a double distributive. You just have to do the 3 times the 4 and the 3 times the 2i. So this would actually be an easier problem to do, right? So that you could have one just like that, right? All right, let's try one more. This time we won't write out every step. We'll just kind of do some of it as we go. Okay. Ashley, what would be the first 2 numbers I would multiply here?
8 and 3.
Yeah, 8 times 3. And can you tell me what that is?
8 times 3 is
24. And then Stephen, what's 8 times I?
8i.
Good, 8i. And Kylie, 3 times I?
3i.
3i. And Melissa, what's I times I?
I squared.
I squared. Okay, Hunter, combine my like terms, and what do I get there?
11i.
Good. 11i. And Ashley, what did we say earlier? I squared equals?
1.
Not 1. You're close. Negative 1. Yeah. So change I squared to negative 1. And Stephen, if I combine my like terms, can you tell me what my final answer is?
23 plus 11i.
That's it. A little confusing when I have 1s next to the I. I'll try to make them look different. So 23 plus 11i. Good. Any questions on that one? All right. So next thing I'm going to show you ultimately is going to help us to do division. Okay, but before we can do division, we have to learn about this thing called a conjugate. So suppose I have a complex number. Just to make it simple, I'm going to call it z. Okay, that's the name of my complex number, z. And z has a real part and an imaginary part, which I'm representing by a and b. If you take z and you put a bar over it, okay, what that bar means is the conjugate. And you pronounce this z bar. And it's the conjugate of z. So all that the conjugate basically means is, instead of it being a plus bi, the conjugate is when you change the sign of the imaginary part. So if it's a plus, you make it a minus. If it's a minus, it would become a plus. Okay, so to find the conjugate of a complex number, all you do is negate. That's a short way of saying change the sign of the imaginary part. Don't do anything to the real part. Just change the sign of the imaginary part. Okay, and we'll practice with some complex numbers and finding their conjugates. All right, so the first one I'll start off with is 3 plus 4i. Anybody think they can tell me what the conjugate of 3 plus 4i would be?
3 minus 4i.
Yep, 3 minus 4i. That's it. That's the conjugate. You'll see what the conjugate is useful for in a second. How about negative 8 minus 2i? Yep.
Negative 8 plus 2.
That's it, just negative 8 plus 2i. How about 5i? What would be the conjugate there?
Negative 5i.
Negative 5i. If you are confused because you don't see a real part, think of it like this. 0 plus 5i, the conjugate is 0 minus 5i, or what we just wrote. How about 3? 3. Okay, if that one seems tricky, think of 3 like this. That's the original. 3 plus 0i, here's the conjugate. 3 minus 0i. Adding 0 or subtracting 0 doesn't make a difference. It stays the same. Okay, any questions on finding a conjugate? All right, next, I want to multiply two numbers that are conjugates together, and I want you to see what happens. So I have 3 minus 4i. That's my number. I'm going to multiply it by its conjugate, 3 plus 4i. We'll do it out just like we did, and something special is going to happen. Okay, Stephen, what's the first thing I would do?
3 times 3.
Yeah, which is
9.
9. Okay, the next thing I would do, Kylie?
3 times 4i.
Good. 3 times 4i, which is how much? 12i. Okay, Nick, what's the next thing I would do?
Negative 4i, 3.
Negative 4i times 3, which is?
Negative 12i.
Good, negative 12i. And Melissa, let's do it in 2 parts. What's negative 4 times positive 4?
Negative 16 squared.
Yep, and then the I times I. There's your I squared. Okay, I'm going to combine my like terms. Hunter, what happens when I do 12i minus 12i? Okay, they canceled out. And I'm left with negative 16. And Ashley, what's I squared? Good, negative 1. All right, so I get 9 minus 16 times negative 1. That's negative 16. And Stephen, what's 9 minus negative 16?
25.
25. What kind of number is 25? Okay, it's a perfect square. Think even more general. Think of like those number categories we learned yesterday. A what number? Yeah, it's a whole number. Specifically, it's a real number. Okay, it's not imaginary. Okay, and that's not a coincidence. Anytime you multiply conjugates together, all the i's are going to disappear. That's why we use conjugates. Right? And look at the first number. It's 3. What do you get if you square 3? 9. What do you get if you square the 4? And if you add 9 and 16, there's your answer. All right, so there's actually a shortcut you can use when you multiply conjugates. What do you get when you square 5? 25. What do you get when you square 4? 16. What's 25 plus 16? 41. Now, if you want, you can go through and do all the foiling. But when you have conjugates, this is a shortcut you can use. If you want to double check it, go ahead and double check it. But it will come out to 41. Okay, so the shortcut formula to multiply two conjugates together is you take A, take the first number, square it. Take B, which is the second number, and square it. and add them up. Doesn't matter if you square 4 or negative 4. It's 16 both ways. So if I gave you something like without foiling it out, what would that come out to? 53. Yep. If you want to double check it, foil it, but I guarantee you the answer is 53. You can't use this trick unless you have conjugates, though. All right. So where the conjugate is going to be used is when we do division. Okay. Anytime you want to divide two complex numbers, this is how you do it. We really don't do division. We change it to a multiplication problem. Okay, so to divide two complex numbers, you want to multiply the top and the bottom of your complex number by the conjugate of what's in the bottom. Basically, the rule is we don't want to leave imaginary numbers in the denominator. So we just learned a trick to cancel out all your imaginaries. Multiply by the conjugate. All right, and we'll start off with this one. Okay. We'll take 1 and we'll divide by 3 plus 4i. Okay, so as the directions say, we're going to multiply. I want to multiply the top and the bottom by the conjugate of what's in the bottom. Okay, Kylie, what's in the bottom of this fraction?
3 plus 4i.
3 plus 4i. And what's the conjugate of 3 plus 4i?
3 minus 4.
That's what I'm going to multiply top and bottom by. Now, here's where knowing that trick to multiply conjugates comes in handy. We should be able to do the bottom very, very quickly. If you don't like the trick, don't use it. Just FOIL the whole thing out and do it that way. But Hunter, can you tell me what the bottom would come out to using our trick? 25. Any question on how he got 25? Just square the 3, you get 9. Square the 4, you get 16. Add them up. Now in the top, we have to distribute. Since we're distributing a 1, is that going to change anything, Melissa? Nope. The last step is to write this as two separate fractions. Here's your real part. The real part over the 25 minus the imaginary part over the 25. You do have to do that. Okay. All the answers on the test are going to be in standard form. So you want to make sure you have real part first, imaginary part separate, not one big fraction. Okay. So you just take each number and divide them by 25 separately instead of all together. And that's it. That's how you divide. Okay. Any questions on that one? All right, so we'll do one more division, and then that'll finish up section A4. This one's a little harder because now in the top, you don't have just a nice number, okay, or a real number. You've got a complex number in the top, and you have one in the bottom. So Ashley, can you tell me what I'm going to multiply the top and bottom by here?
5 minus 12i.
Well, I like the idea you're focusing on the 5 minus 12i. That's the right part of the fraction to look at, but you want the conjugate of it. So what's the conjugate of 5 minus 12i? 5 plus 12i. Always multiply by the conjugate of the bottom. Okay, I like to do the denominator first because it's usually pretty quick. Nick, what's 5 squared? 25. 25. And what's 12 squared? 144. We'll add those up and then the bottom is done. The top, unfortunately, we just have to FOIL the whole thing out. Okay, so Hunter, what's 1 times 5?
5.
And Stephen, 1 times 12i?
12.
12i. Kylie, 4i times 5i? I'm sorry, 4i times 5. 20. All right, good. And the last one, anybody think they can tell me the whole thing, simplifying anything you need to? 4i times 12i. Negative 40, 48, yeah. So the I squared is where you got the negative from, and then 4 times 12, there's your 48. All right, let's combine our like terms in the top. What's 5 take away 48? Negative 43. 12i plus 20i is 32i. And what's 25 plus 144? 169. Can I leave my answer like that? No, it's basically the way I want it. Just split the 169 into 2 fractions with a plus sign between them. Negative 43 over 169 is my real part. 32 over 169 is my imaginary part. And that's it. If you ever ended up with something like this, you can reduce these fractions. Okay? So if you end up with a common factor in the top and the bottom, I would like you to just write it as 1/5 plus 1/5. Okay, just the way that one comes out. Okay, so if you can, always reduce. Okay, questions on multiplying or dividing complex numbers? All right. So last thing we're going to look at is section 5.3. Okay, we'll do part of it today and we'll do the other part tomorrow. First thing I'm going to show you is what's called the complex plane. Okay, if you understand the xy axis, complex plane is super easy. Okay. On the complex plane, basically this gives you a way to graph a complex number. The only thing you do is you don't call the horizontal axis the x-axis. You call it the real axis. Okay, so the real axis is horizontal. Your imaginary axis is vertical. As you head to the right, that's positive. If you head left, that's negative. On the imaginary axis, down is negative, up is positive. So let me show you how you'd graph the point 2 plus 3i. Stephen, what's the real part in 2 plus 3i?
2.
So the real part is 2. Kylie, what's the imaginary part?
3i.
One more time?
3i.
Just the 3. But yeah, the 3. Okay, so real part's 2. Imaginary part is 3. It's just like graphing the point 2, 3. Go 2 on the real axis. Go 3 on the imaginary axis. That's it. That's the point 2 plus 3i. All right, let's try 4 minus 8i. Melissa, could you tell me how I would graph 4 minus 8i?
Over 4 down 8
And when you say over, which way?
to the right.
Yep, right 4, positive 4, and then down 8. And that's the point 4 minus 8i. Nick, what's the real part in this number? Yep, what's the imaginary part? It doesn't have it, so it would be... Yes, this is a real number, and the imaginary part, if it's not there, is 0. Okay, so this is like graphing the point negative 8, comma 0. So how would you graph negative 8? Yeah, to the left 8 units. And we don't go up or down because there's no imaginary part. Good. And Hunter, how about 5i?
You go up or down 0 and, oh no, you go over 0 and up 5?
Yeah, we don't go left and right because there's no real part. Okay, the real part in 5i is 0. The imaginary part is 5. So we go up 5. Okay, and that's graphing in the complex plane. Okay, that's half of what I'm going to show you in section 5.3 today. Any question on that? Okay, you'll have 2 problems on the test where you have to graph. These will not be multiple choice. You're just going to have to do what I just did right here. All right, and the last thing we're going to start to do is to make a connection between polar, okay, what we did earlier in the week, and complex numbers, which we just finished up today. It turns out that if you understand how to write complex numbers in polar, we can do things a lot easier than the way I showed you. Okay, remember all the multiplying and dividing we did? Okay, when you divided, you had to use the conjugate, you had to FOIL it, get these I squareds, you got to change to negative 1s, you got to combine like terms, you got to write it as 2 separate fractions. I can make all that go away. You don't have to do any of that, as long as you understand how to write complex numbers in polar. Right? So that's what we're going to look at next, how we write a complex number in polar. Right? So suppose, again, I'm going to use z to represent my complex number. And my complex number has a real part, which I'm representing with x, and an imaginary part, which I'm representing with y. 2 things. First of all, you might be like, why did he switch letters? We've been using a and b all this time. Well, since we're getting into graphing, now I'm going to use x and y. If you still wanted to use a and b, you could. And the other thing is, normally we put the I after the y. Well, I'm putting it before because the formula that the book is going to give us, they decided to put it before. But technically, you could still put the I after. Okay. That's the rectangular form of a complex number. It's rectangular because x is left and right movement. Okay, we just learned that. That the real axis is left and right. And imaginary is up and down. Now, when we write something in polar, we don't use x and y. Does anyone remember from earlier in the week, what are the 2 letters we use in polar? Yeah, r and theta. So when I'm done, I'm going to have a formula without x and y. Just going to have an r in it. It's going to have a theta in it. Now, earlier, I think it was Monday, we have a formula for x and for y. And I think Nick mentioned it earlier. Does anybody remember what x equals in terms of r and theta? And the one for y is almost the same thing, except we change one word. This would be under converting rectangular to polar. Melissa?
Well, x.
Yeah.
Cosine theta.
And what comes first? You said cosine theta, and there's something in front of that.
R.
R. Good. X is r cosine theta. And can somebody else give me y? Stephen?
R sine theta.
R sine theta. Perfect. So all I need to do to convert a point that's in rectangular form to polar form is take this box, plug it in for x, take this box, and plug it in for y. Okay, so that's what I'll do next. Okay, so instead of x, I want you to write r cosine theta. Okay, copy down your plus sign from up above. Copy down I, we're not changing I. And now fill in y, r sine theta. Okay, and what do both of these terms have in common in front of the trig function? What letter? Yep, they both have an R in common. So whenever two things have something in common, we can do the reverse of distributive property and pull it back out. So I'm going to write R parentheses cosine theta plus, what would be left in the second part if I take the R out? What, Stephen?
I sine theta.
I sine theta. Okay. All I did right there was the reverse of the distributive property. And that is the polar form of a complex number. R cosine theta plus I sine theta. Okay, so let me show you an example of what a final answer would look like. 2 cosine 15 degrees plus I sine 15 degrees. That's an example of a final answer. You don't do anything with that. Okay, so when we get to something that looks just like that, we're done. Okay, the only thing you have to be able to find here, two things. You have to know how to find R, and you have to know how to find theta, which is the same in both spots. We already have formulas for doing that. We're going to use the exact same formulas we learned yesterday. What theorem did we use yesterday to find R? I think it's the only theorem we had yesterday that had a name. Yeah. Use the Pythagorean theorem to find R. And what trig function did we use to find theta? Close, not tangent, but inverse tangent. Yep. So you're going to find R and you're going to find theta just like you did in last night's homework. There's no difference at all. All right. So we'll try a couple of these and that'll be it. Okay, I want to write this number in polar. Okay, let's start by finding theta first. Well, to find theta, that depends on the quadrant. So the first thing I'm going to do is graph that point, figure out what quadrant it's in. Okay, my real part is square root of 3. What's my imaginary part? They didn't write a number in next to I. Yep, -1. Good. So if you want to write that in, you can just put it in. So my real part is positive. My imaginary part is negative. Hunter, what quadrant would that be in if I graphed it?
Be in the top, bottom right.
Yep, bottom right. Positive on the real axis, negative on the imaginary. Doesn't have to be to scale. Okay, just a rough sketch. So now I know I'm in quadrant 4. And Melissa, can you remind me the formula to find theta in quadrant 4?
Inverse tangent. -I over √3.
So, and what's our y value again?
-I. I mean, no, -1.
Yeah, just the number. Okay, so when you fill into that inverse tangent, you should always just be putting the numbers. The real part divided by the imaginary part. Or as we've said before, y over x. And that's it. Just type that in and see what you got. Okay, I'm gonna do mine in degrees. -1 divided by square root of 3. And we get -30. Okay, so that's my angle. And the last thing I need to find is my radius. Okay, Ashley, what is my formula to find the radius?
X squared plus y squared.
All right, so x squared plus y squared equals r squared. Good. Can you tell me what x, or what my real part is here? Good, square root of 3. And Stephen, can you tell me what my imaginary part is?
1.
Careful,
Negative 1.
-1. Again, no letters should be plugged into that formula, just numbers. Okay, let's do it up, see what we get. Kylie, what's the square root of 3 squared?
Maybe 2 square root of
Well, think about what happens when you square and square root. What happens to those two things? They cancel out. Right? So when you square and square root, those are gone. So what's the only thing I'd be left with? Yeah, I'm just left with 3. Okay. And Nick, -1 squared? Yep, 1. So Melissa, my radius would be 2. Okay. Just write those two numbers into your formula and you are done. Don't do anything with it. R cosine theta plus I sine theta. Now, if they asked us to make that a positive angle, does anyone remember what you add to that to make it a positive number?
360.
Yeah. So if you added 360, what would that angle become? 330. So that's another way of writing the answer. Okay, both are correct. Just depends if they want a positive angle or a negative angle. And that's it. That's how you write a complex number in polar. So graph it, find the coordinate, or find the quadrant it's in. Once you know that, either do inverse tangent of y over x, or what might you have to add if you're in quadrants 2 or 3? Yep, you might have to add 180 in quadrants 2 or 3. That'll give you your angle. And then use Pythagorean theorem to find your radius. Do not do this out. If you take the cosine of 330 on your calculator and then distribute the 2 to it, you're going to change this right back to what you started with, which was square root 3. If you plug in the sine of 330 on your calculator and distribute the 2, you're going to change that right back to what we started with, which was -1. Okay, so if you do it out, you're going to change it back. We don't want to change it back. Leave it just like that. Okay, any questions on that? All right, so we've got about 20, a little over 20 minutes left. Okay, so I'm going to give you the rest of the time to work on the homework. Okay, on 560, I'd like you to do 15 to 27, just the odds, and 28. That's on multiplying and dividing complex numbers. And on page 333, 11 to 19, odd. Okay, remember we have our last test for the course on Friday. I will be after school if anybody needs extra help tomorrow, Thursday. Also, if you have any studies, you're welcome to come by then if you need extra help as well.